Hey guys, I want to make a video on factoring. So we're going to factor out the common term, and then we're going to do a difference of square, and then we're going to work with polynomials. And I have a bunch of examples. But before I start on it, I just wanted to kind of walk you through like these little terms, like right here. Let's do like x to the third, right? And let's do like 3y to the second, and let's do like minus 4. Well, let's do 5 for no particular reason. Okay, cool. So this whole thing is called an expression. The entire thing is an expression, right? The numbers up here in the front before the alphabet, just these two, not the 5, just these two, is called coefficient. Efficient? I don't know if that's how you spell it, but that's how I'm spelling it. Cool. Then those are the numbers. The 4 and the 3 are coefficients. Okay, so like these alphabets up here, this y and then this x, those are called variables. And those little tiny dangly numbers in the sky, those are called exponents. Exponents. And then this number 5 that's just naked by itself, nothing is touching it, that's called a constant. Constant. And then this is one term, this is one term, this is one term. So we have 3 terms all together, even though they look different. The terms are separated by what we call an operator, which would be the plus or minus sign. So this is an operator, and this is an operator. Operator. Right? So basically, if you have a number up front, it's a coefficient. The alphabets are called variables. The little dangly number is an exponent. If the number is naked by itself, it's called a constant. And the whole entire thing is called a term. Right? So those are like the parts or the anatomy of like these little math expressions. And it seems like I don't need that. And yeah, maybe you don't. Maybe you're really good at kind of detecting what's being requested of you, like in your exams and like tests and stuff. But what's up is you're going to get questions that have those words in it. Like at some point, you're going to get like stuck on those words. So if you kind of get like an understanding of them now, it's going to help you, especially, oh my God, especially when like the instructor is explaining stuff to you, they're going to throw in these words. And if you know like how to decode it, if you know like the hacks for these, you're going to go really hard. Like you're going to go really strong on all the math that's like up in the classroom. So let's do some example problems. And I'll try to use some of the words in the examples, and then I'll kind of remind you guys like where they're located on like the expression, which this whole thing is an expression. All right, sweet. So the first thing we have is we're going to work with something called common term factoring, right? Or factoring out a common term. So factoring just means pulling something out, right? So we're going to do the common term, which means what's the repeating pattern. So I'm just going to rewrite this. A squared plus 26a, right? This is the whole entire expression. Let's see, what is repeating? What's repeating in both of these terms? See how it says common? That means what is similar. In the terms, we have 2 terms, 1 and 2. We have one operator, that is the plus sign, right? So, and then we're factoring, which means we're pulling stuff out. Well, I don't have numbers in both sides. I just have a 26 and then I have like this invisible 1. I can't do anything with that. So what else can I do? I can use an A. Okay, like that's pretty cool. I could do that. And now if this exponent stuff, I only have 1 of them. But I can mess with an A. I can pull an A out from both sides. So I pulled an A out. So how many do I have? I have 1 A left here, and then I have a 26 here. This is actually the final answer. It kind of looks a little bit weird, but this is the final answer because I just factored it out. So if I were to like put it back in, like if I were to multiply my A against this and multiply my A against this, I would have A squared plus 26A, which is the exact same thing we originally ended up with. That's how you check your work to make sure it's right. But this is the final answer. Let's do another example. So I have t squared minus 35t, and all the alphabets are basically like x. Like this is the exact same thing. Variables are just placeholders. They just mean like fill in the blank, essentially, and they could be any alphabet. Cool. So what can I pull out? I have a 35 and a 1, basically. I can't do anything with that. So the only thing I can do is a t. Let's make that lower. So what do I do? So if I pull a t out of this, what do I get? I get 1 left. And if I pull a t out of the second one, what do I get? I only get a 35. I keep the sign, and that's what I get. If I were to check my work, t times t is t squared. T times 35 is negative 35t. It looks exactly like the question being asked, so it's right. So this is my final answer. These are a little bit easier for people. Sometimes it's a little bit tricky for me personally. Every once in a while I get tripped up. Here's a really good example of like how you can get tripped up. Let me repeat what it says right here. So I have cube, I have square, and then I have like a linear, just like a little normal guy. So there's a bunch of stuff going on. I have alphabets and I have numbers in each single term. I have 3 terms, right? So 3m cubed is a term, 6m square is a term, and then 9m is a term. I have 3 terms. And I got 2 operators. I got 2 of those plus signs. That's not that important. We don't really need to be concerned about the operators. So I know I could pull an m out, but how many m's do I pull out? I have 3 up here, I have 2 here, and I have 1 here. I can't go over the limit, right? So like if something costs like $3 and I only have $1, I can't buy that $3 item because I don't have enough, right? I can't just go crazy. I don't got a credit card. So we can't be using credit cards for like math. So we have to stay within our bounds, okay? So we have to be reasonable. I can only take 1 m out. Why? Because this m only lets me take 1 m out. I can't take 2 out of this one. So I know I can't do 2 or 3 or 7 or 100. The smallest number I could take out is m. The most smallest is not taking out anything, but that's not allowed because that's not the game we're playing. We're trying to figure out common term factoring. So we have to pull something out, and we pull out the smallest amount possible. So I can pull that out. So what does it give me? Well, it's going to give me 3m to the second, right? Because I pulled one out, and it gives me 6m, and it gives me 9, right? So this is not the final answer. This is just what it looks like. Here's the thing. I have a lot of numbers. Can I do something with the numbers, or can I just leave them? Sometimes you have no choice but to leave them because you can't really factor something evenly out. But I have a 3 and a 6 and a 9. I can factor numbers out. What number do I factor out? I have a 3, a 6, and a 9. What works together with these? Well, I can't pull like 2 out because it's going to be weird. I have to multiply. That's the thing. We're not just like subtracting, we're multiplying. So I can't pull 2 out because there's nothing I can put together here that's going to give me an even number. With a 2, I can get a 4 here. I mean, not a 4, a 3. I can get a 3 here, but nothing here. And this 9 is odd. I can't pull anything out here. What about a 3? Here, let's erase this. What about if I pulled out a 3? What would that look like? So if I pulled out a 3, I would get 1 left here for the 3 and the 3. What about 3 and 6? What does that give me if I were to pull those out? Well, it would give me a 2, right? Because 2 times 3 is 6. And then what about this 9? Well, 3 times 3 is 9. So 3 times 1 is 3, which is what I have. 3 times 2 is 6, which is what I have provided in my question. 3 times 3 is 9. Sweet, I can use 3. That's the smallest number I can use. Everything's even. Everything's perfect. I don't need to go into like 4 or 5 or 6. I don't need to test those. So what does that look like? Well, I have to find the matching number. Every single time I've removed a 3. So let's put a 3 here. And then we have to keep the m there. So what does that give me? It gives me m squared. Let's see. And if I pull the 3 out, what does that give me? Well, it gives me 2m. And then what about this 9? Well, I already pulled the m out, so it's going to be a 3, right? Whoopsies. This is my final answer. This is my final answer. So I pulled out the letter M every single time, and then I was just left with numbers. I was just left with numbers. I already pulled the alphabet out. And then I extracted out a common number. It happened to be 3 because we couldn't use 1, we couldn't use 2, and we couldn't use any crazy wild number like a million, right? So we couldn't do that. So the only number I could use is 3. Let's do one more example. I have 12p cubed plus 24p. Okay, this one's a good one. Let's see. It looks like both terms have numbers and both terms have the letter p. So we know we can pull a p out. So we already know what can I pull out? I'm going to pull a p out. So pull. We already know we can pull the p out, but we also have to pull a number out. So which number do I do? I have to make sure that whatever number I pull out, it can multiply against something else and give me an even 12 and give me an even 24. So if I pull out a 1, it just gives me 12 and 24. So there's no point of doing that. If I pull out a 2, what can I multiply against 2 to give me 12? Well, maybe I can pull out, like, give me a 6. You know, I can do like a 6. And then maybe I can do a 12. I can pull that out. I could maybe use 2. But the thing is 6 and 12, I can keep pulling more stuff out. I can simplify it further. So maybe if I pull out a 3, I can get a 4, you know? Well, 4 times 3 gives me 12. And then maybe I can pull out something else. If I did 3, what can I get? Maybe like an 8. 3 times 8 gives me 24. But I could still keep pulling more things out. These are even numbers, right? I mean, if they were weird numbers, then let's try 4. So if I did 12, and then I had to get 4 and 3, I think that would work. And then if I had 24, I could do 6. This would work, but I can keep going. I can't do a 5. That's not going to work. 6, I could do that. It's going to get me something similar to this row. 7 is not going to work. 8 is not going to work. 9, that's almost there, but it's not going to work. 10 is not going to work because it's going to be uneven. 11 is not going to work. What about 12? If I were to take 12 out of 12 and 24, what about that? Let's see. I could do a 1 here because 1 times 12 gives me that. And then what do I have to multiply against 12 to give me 24? Well, 2. I could do that. That's a pretty good way of going. So I knew it was going to be like something around like 2, like an even number. So it looks like I'm going to use 12. And I'm going to use p. So what does that give me? I pulled out a 12. I pulled out a p. What does that give me? It gives me p squared left. Because I already pulled the 12 out, so there's no alphabet. There's no numbers. There's just alphabets, and there's 2 of them left. And then there's a plus sign, and there's a 2. I already pulled the p out. So this is actually my final answer. Right there. Yeah, so basically what you're doing is you're going to figure out if there is a way to pull out a coefficient, which is those numbers up front, and if there's a variable you could pull out. And you're essentially looking for something common. For us, it was the number 12 for this problem. That was common. And then the other common thing was the letter P. And if you're not sure, I mean, you could use a calculator, ideally. But this is another way of doing it. It's just going down like all your numbers, and you're trying to get the smallest numbers possible. I can't go past 12. I can't do 13 or 15 or 20 or 24. I can't do 24 because you're thinking, well, what if we just go there? I can't multiply 24 against something to get 12. It's not possible, right? It's just going back to the whole idea that if you bought something for $3 and you only had $1 in your pocket, you're not eligible to make that purchase, right? Because you need 2 additional dollars to meet your funds, I guess, right? So let's see. Let's try another problem. Let's see. We're going to factor between the 2 squares, right? The difference between 2 squares, rather. So this is just basically like expressing your answer as a product. So like the sum of the quantities from the first step is going to be set up like this. yeah, rather it's going to be set up like this, right? You're going to have a variable here, variable, which is the alphabet. And then you're going to have a plus with a minus here. And you're going to have a number here, like a constant. The constant is when a number is naked by itself hanging out, right? So when you get like a really good cheat code is if you have a negative, if your operator's negative, this is how you set it up. You're going to do a plus operator and a minus operator. You're going to have a variable, which is x, and then you're going to have like a mystery number here. That's it. That's all you got to do. So you really just have to focus primarily on this part, right? Because everything else is like a template. It's always going to be plus and minus if you have two terms like this and you have this negative. If it's a positive, it's going to be a different game, right? So this one's negative. So let's try to see what we can come up with. So this is our setup. It's going to look like this with a plus and a minus. I'm going to have a letter here, and we're going to have a constant here, which is a number, right? So what are we going to do? I know I have an x. I have two of them. So I already know it's going to get thrown up here, right? I'm like 50% done. I just need to know what goes here and here because I already got the signs, plus and minus, set up. So 25. You could do like square root stuff. This is 5. The thing is, like, it takes a minute to memorize these. If you got a calculator, that's going to help you out. But like, what if you're not allowed to use one? What if they're like, just figure it out on your own when you get that test or quiz? What you got to basically figure out is what can I multiply? What two numbers can I multiply that will equal 25, right? And those same exact numbers I use up here, you have to be able to get them to become 0, right? It's going to be either plus or minus. So the exact same numbers have to give you a 0, and the exact same numbers have to give you a multiplication. So that's the name of this game. So what can I put in there? Because I have a 25. Well, let's see. I could try to go down a list. I could do like 1, I could do 2, I could do 3. Let's see. I can do, let's try to make a little table here. So 1 times 25 gives me 25. That's not what I need exactly because 1 minus 25 gives me 24. So I can't use that. So I can't do 2 times anything because it doesn't even multiply to 25. Can I do 3? Can I do 3 times something to give me 25? No. I can't do 2. I can't do 3. I can't do 4. Nothing I can multiply times 4 will give me a 25. What about 5? Let me try 5. 5 times 5, well, that gives me 25, right? And what if I did 5 minus 5, right? I'm doing this part here. What does that give me? Well, it gives me a 0. So I get to multiply something, and I get to subtract something, and it gives me the right answers I need. So it has to add up to that constant that they gave me, which is 25, and it also has to subtract into something that gives me 0. So now it looks like I'm using the 5 and 5. So 5 goes here and 5 goes here. So this is my final answer. Let me clean it up a little bit so you could see what the final answer is. So here's the template. It's a bunch of parentheses. We put the x's here, and then we always do plus and minus if it's telling me minus right here. And then we decided to use 5 and 5. This is our answer. It's exactly the same except the plus and minus sign is changed. Right? Let's do some more problems. Okay, cool. Here's a good one where there's no numbers. It's just alphabets. So I have the letter P and the letter Q. What can I do? It's a minus sign, so I do have that set up, right? So it's going to be P and P like I always get, and it's going to be plus and minus. But what do I put here? I can't just multiply like I was doing earlier. There's no numbers to multiply against. But if you look at p, what I did was I did p, and p gives me p squared, right? Because I have another video where I cover this, right? It's p, and p gives me 2. The formula was m. Oh no, I messed up. This was covered in another video. If you have like 2 little exponents, which we did, we had 2 little ones, it's going to be a n times n, right? And if you have a n times m, which is what we have, we get a n plus m, right? So I guess we have both too. I mean, this could technically fall under both, right? So this is how we ended up with p squared. Well, we could do the same thing with q. I have q squared. What do I do? Q and q equals q squared. So now I know I'm using q and q. So what does that mean? I want to get rid of these. This is q, and this is q. This is my answer. The same concept I applied with p is the exact same concept I could apply with q. Here's another one. So with this, if you wanted, you can always adjust, right? That's something you could do. You could even like remove stuff to make it look like that. I took out a -1. It's not necessary. You can keep it precisely as it is. But these are just alternatives if you want to get, I guess, a bit adventurous. I'm not one for adventure, so I'm just going to use what we have. So what do I do? It's basically the same thing, but it's just flipped a little bit to make it look tricky. We still got that negative. We still got that little 2 exponent. I still have a variable and a constant. It's the exact same thing. They just flipped it. So it's the same concept, h and h. And then because they flipped it, I'm going to do a plus here and a minus here. It's the same setup as I had earlier, which was basically like one of these, right? And then you had to put something here and you had to put something here. It's the exact same thing. I just reversed it, like taking a mirror and turning it over, right? So basically we're going to have something here and here. And it's the same concept, right? It has to be something that multiplies to 144 and something that subtracts to 144. And you have to keep in mind that we have different signs. So what can I use? I have to make a little table. You know, I mean, I could use a calculator, but let's see. You know, this is like a good reminder that if you want, you can memorize the multiplication table. And, you know, they always say, like, a lot of these, like, researchers and stuff and teachers and stuff say that you have to memorize the multiplication table. And if you don't, you're going to have a really hard time in math. And I mean, I don't know. I don't know if that's true. I never actually memorized the multiplication table, but I did enough math where I know instinctually when I see 144, I know exactly what numbers to use. I know I don't even have to think about it. Because if you do enough like math problems after like a couple of semesters, you kind of magically know, you know what I mean? Like, you know, 9 is like 3, you know, like 25 is 5. And you know, for 144, you know, for 49, there's like certain numbers that just really stick out. So you don't necessarily have to spend like a whole summer memorizing the multiplication table. You can just take your math a little bit serious or like take your homework serious, you know what I mean? And through that, you'll just kind of memorize most of it. So just take it seriously somewhere or memorize the multiplication table and take that serious. And then everything will start catching up to you. So with this, we're just going to go through it step by step. Just because I feel like it's important, even if you can see 144 and kind of know what to do. So let's just go over it. So if I did 1 times 1, or 144 rather, that's not something I could use because I can't do the subtraction thing because I have to end up with 0. Let me fix this little box right here. I have to end up with 0. I wonder if I misspoke earlier. I'm supposed to get a 0 and I'm supposed to get a 144. All right. Okay, there you go. Typo video. I guess I messed up. I feel like I said something wrong earlier. I don't remember. Okay. So this we can't use, right? Because I can't just take like 1 and subtract it out of 144. It's not going to equal 0. Well, I don't know. I mean, can I do like a 2? Well, I already know from the jump I can't. I can't do 2. You know, I can't take 144 and then subtract it. And because I mean, what we're doing is we're going to get 72 minus 2. That's just going to give us a 70. I need a 0. Let's see. I can't do 3. I can't do 4. 5 won't even work. So like maybe like a 6. See, like maybe let's try 6. Because like we could do 6 and then we could do like 24. And then that makes 144. But if I subtract these, it's not going to give me a 0. I have very specifically need 0. So I have to keep moving on. Let's see. Can I do maybe like a 7? Well, if it was a 49, we could, but maybe we could do, I don't know, do you want to do like an 8? We could try 8 because 7's not going to work. We need even whole numbers. I think you get like 20 or something with 7, something like that. Let's see. 8 times, yeah, we did 8. 18. That gives me 144. I mean, we're getting close. If I were to subtract these, I would get a 10. So I'm about to hit like a single digit number. But because I need 0, I need to get to 0. I'm almost there. You know what I mean? Because like I was starting off with like triple digit numbers. Now I'm about to hit a single digit number. So let's see, what else can I do? Maybe we could do 9, because like that's the next number in line. Because see, if we did 9, it would be 16 minus 9. That doesn't exactly give me 0. I can't do 10. I mean, I could try to do 11. You know, let's see. So I can't do 8, I can't do 9, I can't do 10. I can't do 11. Well, let's try 12. If I did 12, I'm running out of room. Let me do it up here. If I did 12 and I did it like maybe like times 12 again, that gives me 144. Let's see. So that gives me 144 for multiplication, but I have to make sure it subtracts to 0. So if I did 12, let's see, minus 12, which is what we're using, it gives me 0. So it looks like I can use 12. It looks like that's the number I could use. 12 and 12. Great, I'm done. I just had to do a little bit of basic arithmetic. I didn't even have to do algebra. I set it up like an algebra problem right here. This is the setup of algebra, but I only actually did arithmetic. I just did pre-algebra basic mathematics to get the answer to make it look like an algebraic answer. So this is kind of a way to do it that's going to be easy for you. Let's see. Let's do another one where it's just variables, right? Where a variable is just the alphabets. There's no numbers. This one looks tricky, but don't get overwhelmed, right? So all we're doing is we're going to take the first part and we're going to set it up. It's always going to be set up even, like symmetrical, as long as there's not a number up front, right? If there's a number up front, then we got to put numbers inside our answer. But if there's nothing up here, then it's always understood you're just going to divide it evenly like that. And then, of course, we have a negative. And if we have a negative, it indicates that we put a plus here and a minus here. We're 50% done. I just need to figure out what goes here. What do I have? I have a z squared. Well, we could just divide that evenly, right? Because z times z equals z squared. And then z minus z equals 0. Sweet. I just put a z here. Cool, I'm done. That was like 20 seconds, man. I didn't have to waste any time. Kind of feels like the variables are a little bit easier sometimes. So let's see. Let's do another one. Okay, here's a really good one. So I have a coefficient. When there's a number in front of the alphabet, we can't just throw the A's, we can't just divide the A's and make it look like this. You know what I mean? We can't just do that game. We have to put a little bit of something up front. So we got to figure out what we're going to put up front. This is called a coefficient. Coefficient. Here's something interesting. It's like a weird fun fact. If you look at your expression, which is the whole entire thing, let me erase this. This whole entire thing is the expression. If you have the alphabet at the very, very front, like the super front, it is called a leading coefficient. It's not really much of a difference. It just means it's at the very front. It's called leading coefficient. Think of like a train. This is like where the engine is. I don't know if that makes sense. And then the caboose, I guess, which is the very back of the train, that's the constant. So the leading coefficient is like the guy sitting where the engine is, and then the caboose is the constant, which is the number 9. So that's what our little train looks like. If that makes sense. Like, here we go. Here is our train. Is that what a train looks like? I don't know. Okay, there we go. That's the 4 with the letter A, and then here's our minus sign, and then here's the 9. There we go. Leading coefficient, operator, and then we have our constant, and then our variable is hanging out at the front with the conductor, who is the driver of said train on the track to deliver toys to the children for Christmas. Okay, so what do? Well, I do have that A, and I do have that minus sign, so I am going to set it up with the operators. I do know it's going to be plus and minus, but I got that 4A. What do I do? 4A squared. Well, if we didn't have that 4, if it didn't exist, I'm going to fix that too. We basically know that it's going to be A and A, right? Because A times A is A squared, and A minus A is 0, so I know I'm going to throw an A up here. But what about that 4? What's going on with him? What do I do with him? So let's try our little system we've been trying, right? So 1 times 4, that gives me 4, but the thing is, 1 minus 4 gives me 3, so I can't use that. What about 2 times 4? I'm sorry, 2 times 2. What does that give me? Well, it gives me 4 if I multiply, and 2 minus 2 gives me 0. So I think I can use 2 times 2. I think that's cool, right? So let's put it up here. 2 times 2. Well, what about the back? I have a number 9. They gave me a constant of 9. What do? I apply the same concept. 1 times 9 gives me 9, but it doesn't give me a 0 when I subtract, so I can't use that. I can't use 2 because it doesn't give me anything that gives me an even whole number of 9, so I can't use a 2. What about a 3? What does 3 times this mystery number give me that can equal 9? I could try 3. 3 times 3 gives me a 9. 3 times 3 gives me a 9. And then 3 minus 3 also gives me a 0. And that hits our credentials, man. So if we're hiring for a job, guess what? The number 3 is hired. We can't hire the number 1 because it doesn't lead up to 0. We can't hire 2 because they're all over the place, man. I couldn't even get a straight answer out of them. I just needed a solid 9, and the 2 can't even provide that. So, I mean, I'm sorry, but they're out. The next runner-up is 3. 3 was able to do 3 times 3. It gave me some magical number. It happened to be 3 again. It just gave me a mystery number that equaled 9. Cool. It passed interview 1. Interview 2 for the job was, can you take the 2 numbers you gave me, which is 3 and 3, and then make it into a 0 if I put a subtraction in between? And it did. It totally hit all the criteria. So we're going to hire him to work at our factoring firm. Bam, right there. That's our freaking final answer. Hooray! We're doing wonderfully. And we're rewarded with another problem. Okay, so here's another problem. This is a good one. I'm going to show you something, and then I'm going to show you something else. Okay, so follow me on this one, but careful when you take notes. I don't know who's taking notes, who's watching this. Okay, so here we have the same idea that we've been implementing, right? We're just like, oh, we'll just see the minus sign, and then I'll just put a 2. I'll put a T and a T, and then I'll put the 2 somewhere, and then with 50, I'll figure out a number, and I'll just make it look like this. I'll just make it look like this. Plus, and then minus, and I'll just throw something here, and I'll throw something here, and then I'm done. Okay, well, let's try the idea. Let's try that concept. Because we're seeing this, and it looks straightforward because that's what we've been implementing. Let's try that. What do I do? Well, I have this weird crazy 2. There's nothing I can do that's going to give me the answer I need. I can't take 2 numbers and multiply them together. That will give me 2 and then also give me 0. So what do I do? Well, maybe I could just kind of go a little bit ham here and just do a 2 and a 1. I could try doing that, right? Because 2 minus basically nothing stays 2. It doesn't equal 0, but let's just try it because I don't know what else to do. Let's just try it. And then what about 50? What can I do? What can I get? I could do like 10 and 5. It doesn't exactly equal 0, but it's so close. Maybe I could do a 10, maybe I could do a 5, maybe this would add up. Maybe this could be my final answer. It's not following the patterns I need, but it's close enough. Could this be right? It's not. It's not right. It's incorrect. It has to follow the rules. The rules are that you got to make sure the back numbers, they can be whatever. They don't have to be matching numbers. Like 10 and 5, they don't have to be matching. But they have to, when you multiply the back numbers, it has to equal 50. And when you subtract the back numbers, it has to equal 0. It has to follow the game plan. Because it gives us a game plan. It tells us there's a constant, and then here's a variable, and then here's a minus sign, and you're going to find the difference. And it's giving us the setup, and we're not following the setup, so we're going to come up with a weird answer. And this answer is super, super off. So if your teacher is kind of chill and they give you like partial credit, unfortunately, you're not going to get any credit for this because it's all completely wrong. So that's a bummer. I don't want you to make bad grades if you don't need to. So here's what we're going to do. We are going to factor out something called the common term. We did that earlier. So what do I have? Let's put a line through this. This was wrong. So I had 2t squared minus 50. Well, what do I have? I can't factor out a t in my terms, but I can, they're even numbers. I have a 2 and a 50, so maybe I can factor out some numbers. What can I factor out? I could factor out a 2. That's the best I could do when it's still even. So I got t squared, and then 50 would be like 25, right? So I could factor that out. Now it's looking a little bit easier for me to put together, right? It still has that minus sign, so that means I'm going to have the plus here and the minus here, and then I have t squared. I already know what to do. I just put t's up there. I just have to figure out what these back ones are. But do you see this 2? I gotta move it up here. So my answer is going to look like all the other answers I've had, but it's going to have a 2 thrown up in the front. And what do I have? I have a 25. Or maybe you can look at that 25 and know exactly what to do, but let's just go through it again. I have 1 times a mystery number that equals 25. I could do 25, but it doesn't equal 0. I can't do 2 because it's not going to give me an even number. There's no number I could put in there that's going to give me an even 25. So I can't use that. Same thing with 3, same thing with 4. It's not going to give me, like if I were to put some magical number in there, it's not going to shoot out a perfect 25 when I multiply. This is all multiplication. What about 5? What if I multiply a mystery number against 5 and I'm supposed to end up with 25? What can I use? I can use 5 times 5. Cool, so it passed the first interview. What's the second interview? 5 minus 5. It's supposed to be 0. What does it give me? It does in fact give me 0. It passed the second interview. So I'm going to put a 5 here. This is the final answer. Make sure you push that little 2 in there. He's included in the answer. right? We got that 2 from here because we factored out the common term. And then after we factored out the common term, I went ahead and did something called difference between the two squares, right? Or factoring the difference between two squares. It's the same idea, right? So I did 2 steps. I went back to the original stuff I was doing in the beginning of the video, and then I'm doing this current stuff. So basically, difference of square is you gotta look at the back number, which is the constant, and you have to see if the numbers you pick can multiply out into the number that was given to you, which is the constant. And then can I use those exact same numbers I manufactured to also end up with 0 if I were to subtract it? So that's how you do this. There's another element to look at where you're factoring polynomials, right? A polynomial is when there's multiple terms, anything 2 or more. So this has 3 terms. This is a term, this is a term, this is a term. Remember, a term is anything between the operators. This is an operator, this is an operator. The plus and minus signs. And an equal sign is also one, but we don't have that right here. So basically, we have the same setup, right? We have the same setup, which is this, right? Where you have like a number here, and then you're going to have either a plus or minus and a plus and minus, and you're going to have a constant and a constant, which is a naked number by itself. The only difference is I now will not know exactly what to put for my operators, the plus or minus. Because when I was given like stuff with a minus in between it, like this, I immediately knew that my setup is going to have a plus here and a minus here. I immediately knew that. This time, it's all the same stuff I've been doing, but I'm going to have to figure out what's going to be a plus sign, what's going to be a minus sign. That's really the only big difference here. And that whole thing earlier that I was trying to figure out, like what makes it 0, that's going to come in really handy because it was originally like I got to figure out something that multiplies into the constant which is the constant would be 15 for this, like the back number. It has to multiply out into the back number, and it has to subtract out of the back number to give me basically 0. Now this time we're going to use that in a different way. We're still using it, the exact same methods, but we're going to be able to see in a different way why that's useful. So let's try to go ahead and solve this one. I did a lot of stuff up over here. Let me try to erase some of this. All right, sweet. So basically the game is I gotta figure out what two magical numbers are gonna be multiplied here to give me 15, but adding or subtracting here, that gives me 8, right? So I have to figure out something. Whatever numbers I multiply, it has to give me 15. I have to use those exact same numbers, to give me what equals up to 8, adding or subtracting. So it gets a little bit, and so instead of 0, now it has to be an 8, right? So that's what's up. The third term is going to be multiply. The middle term is going to be addy or subtracty. Let's do addy or subby. Cool, sweet. Okay. And I got to do that weird table. I got to do a whole table. So let's see. What can we use? 15 and 8. Cool. So what gives me that? 1 times 15, that doesn't work. I can't multiply it and end up with some kind of 8. I can't use 2. That's not going to end up with an even number. Maybe like 3. 3 times 5, that gives me 15. Well, that's good. Can I do a 4? No, I can't. What about a 5? Well, it gives me that 3 again. Cool. It looks like 5 is pretty promising. So let's go over here into the 8 side. I could do 1 plus 8. That doesn't work. What about 2 plus something to give me 8? I mean, I could do like a 6. But if I multiply 6 and 2, it gives me 12. I'm almost there. I need 15. It looks like I'm getting closer. What about 3? 3 plus a mystery number gives me 8. What can I do? I could do a 5. right? 5 plus 3 gives me 8. What about 5 times 3? Does that give me a good number? It gives me 15. Well, that's exactly what I need. So it looks like this and this. These are the ones I need. Well, this is the exact same thing. So what am I seeing the repeating patterns of? I'm seeing a 3 and I'm seeing a 5. So it looks like 5 and 3 is what I need. And it looks like it's all addition. So what's my final answer? It's going to be plus and plus. They gave me those x squares, so I'm going to do x. And then in the back, I'm going to do like a 5 and a 3. You can also do, like, if it's addition, you can also do this. This is the exact same thing. I just flipped the constants, the back numbers over. These are both the exact same answer. So this is right, and then this is right. It looks like the answer is 5 and 3. Well, it's pretty exciting. Maybe we could try something else. With this one, it gets a little bit tricky because it requires a little bit more math, right? It requires a little bit more arithmetic. Personally, I think this is much, much faster with a calculator. If you're not allowed to use a calculator or whatever, maybe you can have a cheat sheet. Like if your teacher's cool with the cheat sheet and they're like, but no calculators, bro, just put the whole multiplication table on your cheat sheet if they let you use it, like for exams or whatever. That way, you basically have a built-in, like, old school calculator. It's just on a piece of paper. And then you can just kind of like, let's hustle through it. Just put like the first like 20 on there, like, 1 through 20. For like addition, subtraction, multiplication. Maybe, I don't know. It's going to take up a lot of room. Just see if that's cool for you. Okay, so this time I have a addition and subtraction. We got to be mindful of that. And it's going to be the same setup, right? There's nothing up front, so I know it's going to be x like this. I just don't know if it's plus or minus yet, and I know it's going to be a number at the tail end. So I have like a good chunk of my setup complete. I just got to figure out this is going to be multiply, and then this is going to be either add or subtract. So let's see. I have a 24 and I got a 2. I have a negative 24. I have a negative 24. And I got a positive 2. I almost missed that. Okay, so I have to figure out what goes together to multiply 24. And then if I add or subtract, it gives me 2. So let's see. I can't really do nothing with 1 because I have to get a 24. So the only thing I could use is a 24. That's way too big. Maybe 2. What if I did something with 2 and I multiplied it? Let's do like a negative 2. And I did like 12. Well, it doesn't give me a 24. It doesn't. I mean, it does give me a 24, but it's too big because it doesn't give me a 2. I misspoke. It doesn't give me a 2. I need the final answer to be 2. So that's not good. Can I use a 3? Like maybe 3 is the final answer for this. So if I did 24, or if I needed 24 rather, and I could do like 8, right? That gives me a 24, but does that give me an 8 minus 3? Well, that wouldn't be a 2. It would be like a 5, but I'm getting close. It's a 5. If I just keep going further down, I think I can get somewhere. What about 4? What does 4 give me? If I did, if to get 24 and I had to like divide it by 4, it would give me 6. 4 times 6. That looks pretty, well, this 3 doesn't work. Let's see if that works. If I did 4 minus 6, does that give me 2? Well, it does. It does give me a 2. It looks like this is doing really well. Let's use this one. Let's use this as a placeholder. Let's try to do 2. If I did 4 and 6, what does it give me? Well, if I subtracted, it would give me, well, it would give me a negative 2. I need a positive. But what if I did 6 minus 4? Well, that will certainly give me a positive 2, which is what I need. So I could use this and I could use this, but I need to know if I need to use positive or negative up here on this bottom part. Well, over here I did negative 4. So I can use a negative here and keep the 6 positive. So what does that mean? Well, that means I have x minus 4, x plus 6. That's what I ended up with because we're using the same numbers. And you can even check your work. I do first, I do FOIL. First, outer, inner, last. First is x squared. Outer is plus 6x. Inner is negative 4x. And then last is negative 24. These two are common terms. So what does it give me? It gives me a positive 2. It gives me negative 24. Don't even look at the expression, the question it gave you when you're doing the check work. This is the check work. And just do the math like you're supposed to do it, and then see, does it exactly 100% match up? Well, I have an x squared, just like the question. I have a plus sign next. I have a 2x next. I have a negative sign next. And then I have a 24 that's a constant with no alphabets touching it. This is 100% exactly like the question. Therefore, this is the answer. The little factory thing I made. This is the answer. Let's do another problem. It's the same idea. So let's set up our template first. We have nothing up here, so I know it's going to look like some kind of R here, but we don't know what's going to be up here because I have a 3. It's going to be either plus or minus with a constant. Plus or minus with a constant. So we know that's the basic setup. So what do I do? Well, I could try to work through it. I could try to figure out how many times R goes into everything. I can try to figure out, do I get a 2 here? Does it R2, R1? Is it R3, R1? Like how does this work? I could do that, and you're going to stumble through it. There's not really like a structured way of doing it. Or we can do what we did earlier with one of the earlier problems, which is find the common term. R is up in all of this, so I can take out an R, and then it becomes R squared plus 14R plus 45. So it looks more normal. See that? Totally normal. Now it's kind of more common to what we had, right? So our setup is going to definitely be R plus or minus constant, plus or minus constant. Now there's more reassurance. Now I definitely feel more comfortable knowing what's up. So every time it looks a little bit wacky, try to see, the first step is, can I factor out a common term? Try doing that method, right? Try to get it as close as possible to this, where it's basically a 2, a 1, and a 0, like as far as your exponents go. So let's try to work it out. So again, the whole idea is I need to get something that multiplies 45 and adds or subtracts 14. So 1 times a mystery number has to equal 45. Let's see, what is it? It can't be 45, because it doesn't give me anything close. It doesn't give me anything close to a 14. I can't do 45 with 2 because I have to get an even number. So 2's out of the question, right? Let's do 45. 2's out of the question. 1 was out of the question. What about 3? Well, certainly I can multiply something to give me 45. And if you're not sure, it takes a minute, I could do 15. Well, let's see, 15, if I did 15 minus 3, what does that get me? It doesn't get me 14. It does not get me a 14. It's close though, right? I mean, it's almost close. It's not quite there yet, right? So it gives me 12, but it gives me 12. Let me do 12 here. It's so close. I need 14. So you know what? I'm going to keep going because I think I might be able to get this. What was it? It was 45. So I can't divide it by 4. Let me write this down. I can't divide it by 4 because it doesn't give me an even 25 number. So I can't use 4. What about 5? Do you think I can use 5? Times a mystery number? Well, I could put a 9 in there. Right? If you can't buy your 9s, put your thumb down. It gives you 45. Yeah, that's pretty good. Let's see. Can I use this? can I use this addition? Let's do addition this time. Well, let's actually do subtraction and then I'll do addition because I think that would be useful. So let's see. If I were to take 9 minus 5, I would end up with 4. If I did, I would end up with 4. So that doesn't work. But what if I did 9 plus? What if I did 9 plus? If I did 9 plus 5, it gives me, oh my god, it gives me 14, y'all. Oh, this is working beautifully. Okay, so it looks like I'm using this and I'm using this. It looks like 5 and 9 is totally one of the answers. This is exciting. We're getting so close to the final answer. So let's go ahead and set it up. So, well, let me rewrite it. Right, so we determined that we're going to do r. Don't forget that r up front. Remember him right up here? We had to do that common term thing. He lives here with us. And we decided it's going to be positive because everything is positive. Right, so all I have to do is figure out what goes here. And we already determined it was a 5 and a 9. Bro, this is our answer. We're done. Hooray. That's the final answer. Okay, let's try another one. Okay, let's see. Do I have to look at common terms? No, I have a 2 squared. I mean, not a 2 squared. I have an x squared. So I don't have to do the common term thing. And I do know my setup is going to be x plus or minus a constant, and then x plus or minus a constant. That's my setup. I already know that's right. I just got to figure out what those numbers are going to be and if it's going to be a plus or minus. Keep in mind I have a negative here, so I got to be mindful of that. If it was just a bunch of pluses, you don't have to worry about anything like that. But if there's like a negative thrown in the mix, a minus sign, you got to be real careful. It gets tricky. And remember, we're multiplying the second guy, multiply the constant, and then the one with the variable is addy or subby. Right? Okay. So how do I set this up? Let's do it up here. So I'm going to do a 48 and it has to be multiplied. Let's do a little star for that. And then I have negative 16. You got to be mindful of that. And let's do plus and minus up here so we don't forget. And we'll do our setup. It's going to be 1 times a mystery number has to equal 48. The only thing I can do is 48. That's way too big because it's not going to get anywhere near the 16 I need. So I got to figure something else out. What about if I did 2 times a mystery number to give me 48? I think the closest I could get is 24. But if I did 24 minus 2, that gives me 22. I'm getting a little bit closer, but you know what? I'm really kind of too far away from 16. I got to keep going. What about a 3? 3 times a mystery number to give me 48. So if I mean, sometimes you have to divide. That gives me 16. What if I did 16 minus 3? Well, that's already way too low, right? I need it to be 16. This is giving me 13. It has to be 16. I went too low. Let me just keep trying. Let's do 4. 4 times a mystery number. Let's see. It's like a 12. That gives me 48. Yeah, that gives me 48. What if I did that here? What if I did 12 minus 4? Can I do something with that? If I did 12 minus 4, it gives me 8. So I can't do that. But, I mean, let me see. Let me try something else. These I can't do. So what if I did like a negative 4? Oops. What if I did like negative 4 minus 12? If I did negative 4 minus 12, it actually gives me negative 16. So you can play around a little bit with these. So it looks like these are working really well. So these can be negative. You know, I could do negative 4 times negative 12 gives me a 48. And if I do negative 4 minus 12, it gives me negative 16. I got the same numbers right here. I got the same numbers right here. This part that I'm doing with the adding and the subtracting and the guessing, that's going to be the bulk of your work. I'm just letting you know up front. This little, like, all this bookkeeping I'm doing up in the corner, that is going to be the bulk of your work for these kind of factoring problems. And I promise the more you do them, the easier it's going to get. I promise. I know that sounds crazy because it's like, what did you just do? But it's going to get easier. That's the thing with math. The only thing you can do is just keep practicing. That's the only way to do it. There is no other method. The only other method is like memorizing that like multiplication table, but you can go without it. There's plenty of people who have like PhDs and stuff and they never bothered memorizing the multiplication table. So, and I know what I said is risky. I know everybody wants to memorize it, but just keep doing math problems and I promise it's going to catch up. It all just connects at the end. It does. So what's my final answer? Well, I already know it's going to be an x, and it's going to be an x, and they're both negative, right? So let's just go ahead and set it up like that. Bam, right there. This is my final answer, right? These things, the factoring polynomials, it takes a minute sometimes. Here's a good one. This is the exact same thing that we've been looking at. It's just been flipped. So you can flip it if you want. You can flip it around to make it look easier for you. So let's keep it flipped. So it's all addition. So I know it's going to be x here. I just have to figure out if it's going to be plus or minus. Everything is a plus up here, so my math is going to be super easy. Remember the back part, the constant, is multiplication, and then the middle one is addition or subtraction. Right? So we're making these little Christmas trees. So 1 times a mystery number has to give me 1. I can only use 1. Let's put a plus up here. Let's see. What do? I can do 1 plus 1. Well, that gives me 2. Cool. I don't think I have to do any more math. I think I could just use these 1 and 1. So let's see. Let's go ahead and start working on our template. This is our template that was given to us. We know it's going to be x's at the end because they gave them to us. And they're all plus signs, so we don't have to worry about that. And I was just using 1 and 1. So that's our final answer. We can check our work. You can check your work with all of these. Once you have like the final answer, go ahead and do the FOIL thing. First, outer, inner, last. First, then the outer is plus 1x, the inner is plus 1x, and then the last is 1 times 1. 1 times 1 is actually 1. These are the like terms. So then it becomes plus 2x plus 1. It's exactly the same thing as the original problem we had, except they flipped it on us. But yeah, this is the final answer is this guy right here. I'm just rewriting it because it kind of looks messy up there. It's literally this, which is what I wrote here. But it's just kind of messy now. That's our final answer. It's kind of long-winded. I'm getting a little bit tired, guys. I have a couple of more examples. Okay, here's another one. This is a pretty good one. There's just variables. There's no numbers. So now when you just see variables, what we're doing is we're applying like the theory. Everything we learned, except there's no math. It's just kind of this kind of strategic method, let's call it. Okay, cool. So what do? Well, I don't have a leading coefficient, right? A coefficient is that number in front of the alphabet. I don't have a leading coefficient. So that means I get to set it up like I've been setting it up, which is like a super easy game. Just plus and minus, and then I got to figure out what magical number goes up in here, right? And for us, it might not be magical numbers. It might be something else, right? It might be a magical number because it's at 2, but it might be something else, right? So let's see. What do? Well, I got a negative 2cd, and then I got a d squared. Every time you see a d squared, we know it's going to be d. We know it's going to be d thrown in here at the end. But we got to figure out what goes here because I have a cd also. So let's see. Anytime you see like a square, you know you can evenly distribute it. It's just going to look like d, d. If it's a c, it's going to look like cc. So let's see. Oh, it's a negative. It's a negative. Okay. So with this one, we're going to do, I'm trying to see how to explain this. I have 2 CD. What does that mean? That means I have a CD plus a CD. That's what that means, right? And if I were to multiply that, I would have 2 of them. That's what I would end up with. If I were to subtract it, I would end up with negative CD, 2CD. So what is my final answer? It would be C minus D, C minus D, right? We got that C squared and that D squared, and we got that negative sign. So that's how I came up with this answer. This one was a little bit tricky. I hope I explained that well. I don't know if I did. Okay, here's, how many examples did I give you guys? Oof. Well, who's watching this? I don't know. I mean, it's pretty long-winded. Sorry, guys, to my one listener. Okay. Here's another one. Oh, great. You know what? Look at this. We got a leading coefficient. Oh, how exciting. Okay. We have a leading coefficient. So what do? I cannot extract. I can't do a common term here. 3, 4, and 1, there's nothing I can do with that. Y is in 2 of them. Z is in 2 of them. But Y is not in 3 of them. And Z is not in 3 of them. There is no common term methodology I can use. I gotta just raw dog this. I just gotta go in. Okay, so what do? Okay, let's do 3. Let's try doing a 3 here. 3y, right? And then we're gonna have either a plus or minus. If it's a plus, there's a high likelihood it's just gonna be a plus. That's the thing. But we're gonna just do 3. And then I have a 4. So what do I do here? Well, I have that z. If I have a z, I already know it's just going to be a z. I have a 1 here. Let's try this. Let's just see if this is the final answer. First, then the outer is plus 3yz. Then the inner, because we're multiplying, the inner is plus zy. And then the last is z squared. These are the common terms. So I have 3y squared, plus 4yz plus z squared. It looks like it is the exact same thing as the as the answer, the initial answer. So it looks like this is correct. This is correct. We didn't really need to do any math. We just followed strategy. We saw that we couldn't do a common term, so we just applied y3. Anytime you see a number with a square, you can evenly distribute it, right? And we did that with z's. We just put a z here, and we put a z here. And then we just took a chance and just started doing the math. We didn't have to necessarily think about anything. We just placed things down. I think this is the last one. Yeah, this is definitely the last one. So let's go ahead and work on it since it's the last one. So it looks like I do have a leading coefficient again, but I cannot do anything with 7, 20, or 3. Wait, cannot? No, I cannot. And I don't have an A on all 3 terms. It's just on 2, so I cannot do the common term thing. I can't pull out something that matches all 3 terms. So I just got to go in. So what do? Well, let's see. This one is a little bit different. Let's try to see. They're both negative this time. So with 7, I can't do anything with it. So I just have to do 7a. And I'm going to do an a on both sides. I can't divide 7. I can't distribute it in a different, I can't do like a 3.5. I can't. So I have to just do 7 and an a. And then with 3, I can't do anything else with it. I have to keep it 3. So it's going to be either 3 or 1. It's possible that I put a 3 here instead and a 1 here, but I'm going to try doing it with just the 1 and the 3 here. I might have to mess around with it a little bit. And it has negatives. So if there's 2 negatives, one method you could do is just do that method right here, where you just put a plus and a minus if there's 2 negatives. Let's try to test it. Let's test and see if this is right. So first, then outer. Oof, it's going to be 21? 21? No, it's negative 21. Let me subtract that out. Negative 21a. Then the inner is plus a. And then last is negative 3. Cool. So the last 2 is exactly correct. I got to make sure the middle part is right. Negative 20 plus 1 is actually negative 20a. And then we have the same thing we brought down. Negative 3. Okay, cool, sweet. This is the right method. This looks right. Okay, cool. So it turns out our answer is this up here at the very top. So sometimes you can just throw things down and guess. If there's no real math to do, sometimes it's just technique. And we went through a lot of problems, so we were able to start identifying technique, if that makes sense. Hopefully it does. Okay, I hope this helped. I hope I was able to explain it with some level of competency on my side. I hope it was useful. I do have stickers in my sticker shop if anyone wants to take a looky-loo or gander. Okay, thanks guys, bye.